Hello everyone. All right, so in this tutorial I'm going to provide solution to this electromagnetic wave problems. Okay, now the first one here is the one about photon of radiation. So we have here that the energy of a photon is 2.5 electron volts. Now we know that electron volt is the amount of work done in carrying or moving an electric charge of one coulomb through a potential rise of 1 volt. So which means energy can also be measured in electron volts. Now, what is the principal radiation for this photon? Now, when questions like this is asked, that what is the principal radiation for the given photon energy? Now, it means that we need to find out in what region, okay, of the electromagnetic radiation or spectrum of light, okay, the wavelengths, okay, when we are giving the photon energy, what region in the electromagnetic spectrum or radiation does the wavelength lies? So to find out the wavelength, okay, we're going to set up the energy wavelength equation, okay, to be able to calculate the wavelength. And now we know that according to quantum theory of radiation, now we have that electromagnetic radiation consists of particles called photon. So when we talk about photon, okay, now photon is the energy of light, okay, and we always have them to travel in a bundle packet across an empty space. That's vacuum, because this is what electromagnetic radiation. All right, so the energy equation, and also because we know that a photon has zero mass or rest mass, but it has momentum and energy. So we can write the energy equation for one frequency. That's the energy equation, okay, for a single frequency of light. That's energy of photon. Okay, that is the photon energy of photon. So we have the equation to be HF, and we can rearrange this, or we can write this again as H equals to H, that's E equals to HC over lambda, because we know that frequency is C over lambda. We know that frequency from C, okay, equals to F lambda. Now we know that frequency is what? C over lambda. So this is very important. So now we know that C is the speed of light, and the value of speed of light is 3.0 times 10 raised to the power of 8 meters per second. Then also, this is the wavelength. So this is the one we need to what? Get its value. So now we're giving the energy of photon, and the energy of photon we are giving is in electron volts. I just said that I said the amount of work done, okay, in carrying a charge of 1 coulomb through a potential rise of 1 volt is what we call electron volt. So which means that energy can be measured in what? Electron volt. But we need to convert this energy, which is given in electron volt, into joules. So we have energy which is equals to 2.5 EV. Okay, so this 2.5 EV, to be able to convert it into what? Joules. So we have in joules, that will be equals to 2.5 multiplied by 1.602 times 10 raised to the power of what? Minus 19. So the unit will be what? Joules. All right, so now what is 2.5? Let's get what is 2.5 multiplied by 1.602. Okay, that will be 4.005. Okay, so we have the energy in joules to be 4.01 times 10 raised to the power of minus 19 joules. That is the energy in joules. But we need to calculate the wavelength. So from here, okay, now the wavelength, we know that to calculate the wavelength will be, we can rearrange this equation so that we can have wavelength equals to hc over what? Energy. So the wavelength is equal to Planck's constant, Planck's constant, which is 6.63 times 10 raised to the power of minus 34 joules seconds. Then times 3.0 times 10 raised to the power of what? 8, which is the speed of light. Then all over the energy, which is what we have here, as 4.01, okay, times 10 raised to the power of what? Minus 19. Minus 19. Don't forget that Planck's constant is 6.63 times 10 raised to the power of what? Minus 34 joules seconds. That's Planck's constant. So now let's get the value for 6.63 multiplied by 3. Now that will be 19.89. So we have 19.89. Now we divide that by 4.01 times 10 raised to the power of minus 34 plus 8. When we combine the powers of 10, and we also move this guy up, that will be plus 19. Okay, so then we can now divide 19.89 by 4.01. Dividing it by 4.01, we are going to obtain 4.96. Okay, so remember, this is in what? Meters. That's the unit of wavelength is in meters. So we have 4.96. So here we have wavelength to be 4.96 times 10 raised to the power of, now 19 plus 8, that will be 27. So what is now 27 plus 27 minus 34? That's going to be 27 minus 34. That's going to be minus 7. Yeah, minus 7. So this would be minus 7 meters. So we have, okay, with wavelengths, okay, between 400 nanometers for violet light to 700 nanometers, which is for what? For red light. So which means that in between, we're going to have, in between, we have the median colors. So the median colors for this will be the green blue light. So which means this will be what? This wavelength will lie in the what? In the green blue light region. And that is the answer to the question. Remember, it lies in the green blue light region. It lies in the green blue light region. Yes, green blue light region. Right, beef. All right, so that's for number 1. Now for number 2. Now let's have our solution for number 2. Now for number 2, okay, we have here that this question is about investigations involving electromagnetic waves. A vertical transmitter area, okay, emits a vertically polarized electromagnetic wave which travels towards a vertical receiver area. Okay, when we say polarized, you know, polarized is when we make unpolarized light, you know, to become what? Polarized. That is, the vibration of the electric field vector with respect to the vibration of the magnetic field vector will be what? Will be along a plane, and it will be perpendicular, and that will be along a plane. So we have the vibration here. So we have the oscillating electric field. Okay, this is the magnetic field. So we have here that the wavelength of the wave is 0.6. So we are given the wavelength, which is 0.6 meters. Okay, the figure below shows a short section of the oscillating electric field of magnetic wave. Okay, so this is the transmitter and this is the receiver. This is the detector circuit, okay, which detects the what? The wave being transmitted from the transmitter area. Okay, so we want to calculate the frequency. Now the wave is a polarized wave, and which means we're talking about what? Electromagnetic wave, because of all the characteristics, of all the properties of waves, which are the reflection, refraction, diffraction, interference, or superposition, and also what? Polarization. Now the mechanical waves can only exhibit those 4 properties, except the what? Except the one we call polarization. So which means that the speed of light will be what? Will remain as 3.0 times 10 raised to the power of 8 meters per second. So the speed of light is 3 times 10 raised to the power of 8 meters per second. All right, so we want to calculate the frequency. So we know from the formula C equals to F lambda. We know that F will be what? C over lambda. So that means 3.0 times 10 raised to the power of 8 divided by frequency. Now, the wave is a polarized wave, and which means we're talking about what? Electromagnetic wave, because of all the characteristics, of all the properties of waves, which are the reflection, refraction, diffraction, interference, or superposition, and also what? Polarization. Now, the mechanical waves can only exhibit those four properties, except the what? Except the one we call polarization. So, which means that the speed of light will be what? Will remain as 3.0 times 10 raised to the power of 8 meters per second. So the speed of light is 3 times 10 raised to the power of 8 meters per second. All right, so we want to calculate the frequency. So we know from the formula C equals to F lambda. We know that F will be what? C over lambda. So that means 3.0 times 10 raised to the power of 8 divided by 0.6, okay? And this will be 3 times 3 over 6. This will be 3 over 6 times 10 raised to the power of 8, okay? Multiplied by 10 raised to the power of minus 1. The unit of frequency is what? Is the Earth. So 3 divided by 6. So we have frequency to be equals to 0.5 times 10 raised to the power of, when we bring this guy here, it will be 8 plus 1. And this will be in hertz. Now, 0.5 is the same thing as 5 times 10 raised to the power of 1. So the frequency in this case is going to be 5 times 10 raised to the power of minus 1 plus 9, which will be what? 8. So which means the frequency, okay, of the transmitted wave. The frequency of the transmitted wave is the what? 5 times 10 raised to the power of 8 hertz. Bye-bye.